Hi everyone, this is Arivalang from Konganadu College of Engineering Technology. Sir, we are going to see the heat and mass transfer subject. So it is a familiar subject of Department of Mechanical Engineering. So in that we are going to see that the first unit, it is a conduction. In that conduction, we are going to see that in composite walls problem. So first we going to read the problem. So we are solving the composite problem. So we are having three layers. So in the three layers given for that, cement, cork, brick, these are the different materials having and different length of the wall is having. Okay. So one by one we are going to see that the wall of the cold room is composite of three layers. So the outer layer is brick, that is a 330 centimeter thickness, and the middle layer is cork 20 centimeter thickness, and the inside layer is cement 15 centimeter thickness. So these are the thickness of the walls. Okay, so we are taking the thickness is the length. So thickness is the heat transfer length. Okay, so everywhere we are taking that the length means the heat which area this going to the heat will be transferred, that much of length is the we are take that much of heat transfer length is the we are overall length values we are taking that and then for solving the problem. Okay, so here the three layers length is given. So that is that means of brick and cork and cement. The value is given corresponding 15 centimeter, 20 centimeter, 30 centimeters. So these are the L values. Okay. So corresponding in the K value is given. So what is the K value? The capable of heat transfer capacity, that is called as K value. Okay, so every materials having particular K values, it is not for same for all the materials. So we are using that three materials. First one is a brick and a cork and a cement. Okay, so corresponding K value is given, that is a conductivity value. The brick conductivity value is a 2.4 watt per meter Kelvin, and the cork conductivity value given 0.05 watt per meter Kelvin, and the cement conductivity value given 0.28 watt per meter Kelvin. Okay, these are the conductivity values. Then the temperature is given. The temperature of the outside air is 25 degrees Celsius, and the inside air temperature is 20 degrees Celsius. The film coefficient for the outside and inside is given. The film coefficient, heat transfer coefficient, that is the H value. Okay, so outside area of H value is 55.4 watt per meter square Kelvin, and inside heat transfer coefficient is 17 watt per meter square Kelvin. So finally, we are going to find the value of uh, heat transfer area. Okay. So these are the values given for that our problem. So first we are find the values Q by A. Okay. So what is the formula for Q by A? See, in general we are taking the formula Q equal to del change in temperature, that means of del T in overall all the temperatures, that means of inside to outside temperature. Okay, divided by R. So that is the R value is the resistance. So in the resistance means, so you are opposing the heat transfer rate. Okay. So what we can find the values when the formula is the length of the material divided by particular material conductivity into area of the material. So these are the this is the formula for R. So here we are forming the one formula for R. So having three layers and also heat transfer coefficient inside and outside. Okay. So these values we are derived in one formula 1 divided by HA into A plus L1 divided by K1 into A. That is the first layer. Then plus second layer is L2 divided by K2 into A. Then third layer brick is L3 divided by K3 into A plus outside is a convective heat transfer coefficient is given. So the 1 divided by HB into A. So this is the R formula. We are substituting the in Q formula. So in the del T and R values, so it's given. Okay, so then we are going to solve that value is Q by A, that is a heat transfer per area. Okay, that is a heat flow rate. Okay, so then we are taking the area in left side, that means of Q by A, that equal to remaining all the terms are having. Okay, so in that formula we are having the we need the temperature, convective heat transfer coefficient and L value, conductivity value. So these are the given for our problem. So we are substituting these all the values in that heat transfer heat flow rate of formula. So we are finally getting the values minus 9.5 watt per meter square Kelvin. The sign value is negative. So that is a cooling area. Okay, that means of not for the heat. Is improving the not for improving the heat. There is a we are we cooling the medium. That means of the negative signs. Okay, thank you for watching.